Hi, everyone. Welcome to this week's DeSci Labs product community call. Excited to have all of you here, and I'm very excited for the subject of today's community call, which is going to be all of Ian's work around the general index. So, a little bit of an overview for how we're going to structure this call today. We're going to start off by giving some quick updates around the product community itself, everything DeSci Labs related, some of the upcoming events. Then I'm going to pass the microphone off to Chris, who's going to give us a little bit, maybe a 5-10 minute introduction or a refresher as to what the general index is and why it matters. From there, we're going to hand the mic off to Ian, who is going to talk about a lot of the work he's done with the underlying data and what he's been able to build and has been able to find. So with that being said, I'll go ahead and get things started with a couple updates. So exciting week, as always, with DeSci Labs. We've been lucky enough to be involved in quite a few things over the past little while. So for starters, some of the things that we will be doing, Philip is going to be presenting at ETHCC in Paris, all around impact certificates and science as a public good. So some of the funding methodologies for science. That's going to be happening from 4:05 p.m. CET to 4:20 p.m. CET in the Sorbonne. So anyone who is in Paris and wants to go listen to him speak, we would love for people to come to the audience, ask questions, and really start to facilitate discussion around impact certificates and the larger DeSci space. Research Hub is going to be hosting a SciCon, a virtual, I believe they call it a build-a-thon, where Chris and I are both going to be speaking about different subjects. So I'll be talking about onboarding the general public to science and kind of rebuilding some of the trust networks there. And Chris is going to be talking about open verifiability and reproducibility in science and how existing Web3 technologies can be used to facilitate that. Both fantastic talks. We'll be posting more about this both on Discord and on Twitter. So anyone who has questions there, feel free to ask. As always, we have the normal lineup of weekly calls. So there's going to be an onboarding call that's happening, I want to say tomorrow. Let me check that to make sure. Product support office hours is tomorrow at 1 p.m. So if you're an alpha tester and you have questions around the DeSci Labs product, that's your place to ask. We're going to have an onboarding community call on Wednesday for anyone who has questions around the larger DeSci space or DeSci Labs in general. So feel free to join both of those. Then I think beyond that, we're trying something new this week, which I'm excited about. It is a coffee house structure. So these community calls tend to be a little bit structured, which is good. We get through a topic, there's a lot of wonderful discussion that happens around it. But it's also nice to have an unstructured space to just get to meet other community members. So immediately after this call, in the exact same channel, you don't have to leave the channel itself, we're going to just open up the floor to a little bit more unstructured discussion where people can meet each other, kind of talk about their backgrounds, their interests, what brought them to DeSci Labs, and any other important questions. I think Jay Ringo really wanted to get people's opinion on whether sandwiches or hot dogs are sandwiches, which the correct answer is no. So with that being said, that's a pretty comprehensive look into the events coming up. And I will go ahead and pass off the microphone to Chris so he can give a quick overview on what the general index is and why it matters. Chris?
Sure. Hey, can you hear me, everyone?
Yep, loud and clear.
Great. So the general index is this incredible data set of, I think, 100 million scientific papers that have been essentially digested to be non-consumptive and presented in Ngram, which is a format that's used in machine learning very often for classification and other types of algorithms. It's quite an incredible data set because it essentially contains the majority of published scientific work in a format that's non-consumptive and that therefore doesn't infringe on copyright. What does that mean? Well, that means we have at our fingertip the possibility to derive some really interesting insights and to create the types of actionable intelligence that would allow us to create better products and to improve different parameters surrounding science and research. So to give you a little overview of the type of things that are doable, we could use, for example, the general index to create classification schemes that would allow us to automatically generate metadata, for example, tags to allow search engines to find scientific articles more accurately. We could typically use the general index for finding reviewers. So reviewers are now quite typically found using citation graphs. We can actually use measures of similarity between published papers, between the different tags on which they would saturate to find reviewers. We could essentially leverage that data set and even enrich it with other data sets, such as the one that's called Open Citation. The Open Citation project is a project to put citation data out there in the open, which is typically something that's monetized by Clarivate Analytics and other big providers and trackers of citation analytics. So now there's this other incredible data set that's out there that we could cross-reference with the general index. So all of this allows us to start peering with algorithms into the fabric of knowledge. And we could be extracting some very, very valuable information from that. Of course, let's say the longer tail of all of that is that these types of data sets could be used to enrich very large language models. But that would be, far beyond the scope of what our community is capable of doing, given the computational cost and the type of expertise that's required. But for our purpose, for example, using that data and studying how we can use clustering algorithms to recompose either in supervised or unsupervised learning manner to essentially derive tags so that we can automatically classify articles and papers that are published in a DeSci system with generated tags and other metadata indicator that would simplify findability and also ultimately improve the user experience for authors. We want to make it as simple as possible to publish your work without having to navigate through endless fields where people have to manually enter metadata, which is very error prone. We could do a lot of that metadata generation automatically using tools for machine learning applied to the general index. So for these reasons, for us, it's a very exciting data set. And I'm really looking forward to what people in this community might come up with. I know we've had Haitian who's been contributing some really interesting ideas, and I'm really looking for what are the other things that could come about it. So yeah, that's my 5 minutes about why the general index is exciting, and I'm looking forward to the conversations.
Thanks, Chris. And with that being said, Ian, who's on the call with us right now, has been doing a ton of work actually hacking away at the data in the general index. So Ian, do you want to just quickly talk to us, or I guess for the next few minutes, talk to us about what it is you've been doing?
Yeah, absolutely. I think that was a really great overview from Chris on the general index and what it's actually storing and its potential use cases. So what I've been doing is trying to actually work with the n-grams and the underlying general index and understand how they can be used and what makes the most sense in terms of pre-processing and what models work best for the given applications that Chris mentioned. So as you said, the index is non-consumptive. It stores all the manuscripts as n-grams, which is really nice, actually, that they pre-process that. It's having 100 million full manuscripts would just be completely infeasible without a large team of NLP researchers to work with and data engineers. So they've done that job for us already. And the next steps is really just how do we want to use these n-grams and input them into models. So I've been looking at a couple different ways to pre-process these strings and create vector embeddings for machine readable models and to actually understands the similarity between words and topics using these n-grams. So I looked up using the term frequency, inverse document frequency models, very, very common to understands the importance of a particular word within the underlying manuscript, basically how frequent it is in the document. And then a couple other ones, slightly more complicated, are the word-to-vec vector embeddings, which is under the hood a neural network that determines the similarity between words and their meaning and creates vectors to represent each word. And that's really helpful because you can use that to calculate the cosine similarity very quickly and understand how similar words are to one another. It suffers a little bit. Well, it's an input for a lot of models, but it suffers a little bit in that it just looks at individual words and strings, and it doesn't do a perfect job at understanding the context of words. So I also looked at a doc2vec vector embedding, where it would look at a whole document and create document vectors, which is basically a generalization of word to vector that can understand the context of particular words. So these are basically just different ways of taking the n-grams and transitioning them into some sort of quantitative vector matrix, pretty much, that can be fed into a model. And then from there, we get to the fun natural language processing models. So I'm looking right now at 4 different models based on a paper I found comparing the topic extraction from tweets. So I thought that was a pretty relevant use case in terms of just not having a ton of words to play with, but still being able to extract topics. So of the 4 models I'm looking at, they're basically split up into 2 different categories. One of them is discrete topics, where it allocates each document into a particular topic. And then the other ones are more continuous topics, where the topics are along a continuum and there's slightly more flexibility for hierarchical topicing and subtopics. So the first 2 are Lda and Nmf. So Lda stands for latent Dirichlet allocation. It's probably the most common topic extraction model to date. It's a generalization, to my knowledge, of latent semantic analysis, and it basically just pools the documents and creates topics based on the most frequent words and clusters that it can form. And then non-negative matrix factorization is a very similar model, which again puts discrete topics and uses, as you could guess, linear algebra to deduce the topics. These 2 models are really nice in that they're very fast and easy to implement, but they are slightly problematic in some ways. So for starters, the number of topics that you input to each of these is a hyperparameter that requires optimization. And with the context of 100 million publications across, I believe, 35 billion n-grams, that would require running through the model for each hyperparameter we want to select. And it might be difficult to guess beforehand how many topics are in there. So that's definitely something to keep in mind. And that's kind of where the other 2 models fit into this type of scenario. So I'm looking at the top2vec model, or topic to vector model, which is essentially a second generation generalization of the doc2vec model. And it can pull out topics from these vector embeddings of documents. And it's a rather incredible model to look at. And it doesn't suffer from that same hyperparameter optimization. So the model itself will actually determine the topics and the number of topics required. And then the other one is BERT topic. This is slightly more well-known topic modeling. I believe it's the one used by GPT-3. And it does, similar to top2vec, it uses transformers to look at the prior words, actually additionally determine that context of the word. And I believe is pre-trained with the universal sentence encoder, which looks at, I believe, all of the Wikipedia articles ever posted. So it does a really good job at pulling out semantics with words as a result of it being pre-trained on that. And however, with these 2 models, they're quite difficult to implement. I've had quite a few troubles with incompatibilities in existing libraries and trying to actually get these to run on my code. So that's been a little bit of a headache and something to definitely note, but the nice part is that you don't need to optimize the hyperparameters regarding the number of topics. So with these in mind, I'm doing most of my work in a GitHub, which I believe I've posted in the Discord, and I have a couple of next steps in the immediate future and also in the slightly longer term future. So I want to really finish implementing and validating the top two VEC and BERT topic models and compare those to LDA and NMF. I also want to look at a couple different ways of actually validating these models. So natural language processing is quite difficult in that it can be quite difficult to validate the model and that its output actually makes sense because you're dealing with such broad input and output data. It can be tough to actually determine to comb through every single piece of training data and see the topics that it was put in and validate those. That's a very non-trivial task. So there's a couple techniques to get around that. One of those is the coherence metrics, which is basically understanding how coherent the topics are that the model outputs. And then the other one is information gain. So anyone that knows about entropy knows about the way information is stored. And it's basically as you increase the number of topics, how much more information can you actually gain out of the model? And it can do a pretty good job at understanding is the model actually learning more or is it kind of becoming saturated in terms of the information that it's learning? And then finally, I'm working towards actually moving these models up past the testing data set into a slightly larger slice of the general index. So right now, the testing data set is very nice for quickly working with it. It's got about 1,000 papers in it across two main topics, antediluvian and NEC86. So it's nice for really quickly pulling apart, can you build a model that can differentiate between these two topics? But when we're dealing with a significantly larger data set where we don't actually know the number of topics, I think it's important to start working with pieces of data where we don't actually understand necessarily what the underlying topics are or how dense each of them are or the different subtopics that could be relevant in them. So I think a good next step would be to try and pull maybe the first 100,000 or the first million papers or n-grams from the SQL database and run these models through that to see how well they do. And then in terms of future applications, Chris mentioned quite a few of them, and I'll just touch on them here. So I think of particular interest to me is peer review selection. So being able to quickly figure out the peer reviewers who have published or reviewed manuscripts in a particular topic and subtopic, I think is a very interesting use case for this, especially in the context of decentralized science publication. And I think it's also pretty cool because you could do this and you could select peer reviewers without revealing a whole lot about the underlying manuscript. You could pull out its n-grams from the corpus, and then given those topics, subtopics, the peer reviewer, we have a manuscript with these topics. Would you, like to review it, such and such, without actually having to give them the abstract and give them any bias going into the process. But peer reviewers might be, more inclined to accept reviews for manuscripts that or abstracts that they think they would accept because they have an easier job on their hands. Another interesting one, again, that Chris mentioned, is an automatic metadata generation for a manuscript. Could just automatically assign metadata to the topics and subtopics and the underlying manuscript and just make these nodes or manuscripts more machine readable and just easier to access without requiring the author reviewer to manually assign. They could just check the metadata that were assigned. Some more complex, but I also think very interesting use cases for this could be aggregating papers on a particular topic for anyone doing literature review. So I think someone mentioned the Elicit Research Assistant. That's very much the same thing. I believe that one scrapes the web, but doing something like this where if you give it a particular topic or even just a manuscript, it can just give you the most similar manuscripts and give that back to you, especially, given the granularity or specificity of the topic we're looking at. And I also imagine that there's quite a few more use cases for the general index, which I guess is where the community members come into play here. I can't envision that, one or two people could actually think of everything that this could be used for, and any other models that general index could be used for. So that's just about everything I have today.
That is really awesome. I want to add, I think that, yeah, you've done a really great job at going over quite a few of the models that do classification. I really like the part about having a model that, so these are all unsupervised learning methods for you guys out there. They're essentially working without like trying to predict existing metadata, but there's a whole other category of tools out there that also allow you to take, the metadata that's been extracted from Crossref. We could essentially have a system that tests or has a pass for metadata that's sufficiently high quality, and then that tries to predict some of these metadata elements, for example, pre-existing tags, right? Pre-existing tags that could be associated with articles. And we can essentially try to run classification and to assign these tags to a corpus of work that have defective metadata, right? And that would allow us to substantially enrich and repair the quality of metadata in science, which, as we all know, is quite lacking because of different norms exerted by repositories, also especially for older articles that are still have defective metadata. So there's also a whole part about that, which is not only about findability, but it's also about repairing the scientific record and making it more easy to navigate. So yeah, so these I think are like super interesting applications. We could also, for instance, use the type of observed metadata tags and use that to constrain the unsupervised learning models with pre-existing categories to cluster around. So that would be another approach that I could see could be valuable. Yeah, in general, I think there's really so much things we can do. I'm very curious to have other community members, propose some applications, or maybe even just propose people that might have ideas for applications, and we could then, invite them in our Discord, have them join our community to enrich our efforts around using the general index to improve the quality of metadata, and also as a recommender system for finding reviewers or other types of work. And finally, there's also the possibility of using that type of data to classify what an article is about. Is it a literature review? Is it an original research article? Is it a meta-analysis, right? Because we might be able to automatically rely on certain types of textual NLP information, a statistical structure that's embedded within these n-grams that would allow us to classify them into one of these well-known categories of scientific research, right? So there seems to me that there's a plethora of really interesting applications that could be used there. And I think this approach where we take a small subset of the general index with clearly defined categories and we test out different models, what they're able to tell us, that's a very, very fruitful way to do fast prototyping and to eventually converge as a community towards a solution that might scale really, really well. After which we'd do an API implementation and we'd essentially run it on a supercluster to get to the end of it, right? And we'd sponsor, of course, all of those efforts, and we could really stumble on something that could be absolutely amazing down the line.
So I see a question in the community chat from Ellie. It says, quick clarification, my perception was that the general index only had abstracts for papers. So when you say you're doing Doc2Vec, are you doing this only with abstracts? Ian, I see where you're typing in chat, but it may just be easier to respond verbally.
Yeah, absolutely. So for the Doc2Vec embeddings, I'm just feeding it like the whole n-grams associated with the paper. So basically each paper has at least one, but in many instances, dozens of n-grams associated with it. So as a part of the pre-processing, one of the pieces of data I'm doing is just taking all the n-grams and putting a period after them, and then appending any additional n-grams associated with that paper into it as essentially an additional sentence. And then feeding that into the Doc2Vec embedding model. basically like, creating a document out of the n-grams and then creating an embedding out of that, which is proven to be actually somewhat good at pulling out the topics, but definitely open to feedback on that rationale.
All right, sweet, thanks.
Hey, Ian, thanks for the great overview. And Chris, do you, from your experience working with the General Index, would you have any tips if someone was looking to get involved with trying to code on it?
Absolutely. So I would definitely start with a testing data set. It's a very small slice of the general index, but it's very workable on pretty much any machine and just gives you an idea as to the different information that is given in the underlying data set. I have a GitHub repository, and I'm trying to make like basically a framework notebook for importing the general index, doing some basic pre-processing, and then starting with some models, basically for anyone getting started that maybe wants like something to start from versus just doing all that from scratch. So I will definitely be updating that in the coming week. But if you wanted to start from something that's not just like ground zero, I might recommend starting with that just to see what the data looks like and how to actually work with the n-grams themselves.
Yeah, that's awesome. Thank you for all your hard work. Looking forward to checking that out. Also super excited to hear about the potential for peer reviewer systems based on the General Index, or just like being able to find reviewers. Because I know that's something that we've had a problem with in running some of our peer review experiments over at Scurf. And if there was a general index subset data that we could easily pull of like, oh, here's all the research happening on DAOs, that would make a lot of our lives really easier. So I might be digging into how to do that.
Yeah, absolutely. Thanks for kind words. I think maybe making like would be further down the line, but making some kind of API to query the model might be beneficial for the applications that you're talking about. If you want to pull all the papers similar to or about a particular topic or subtopic, I think that could definitely be a future use case for such a model.
Yeah, that would absolutely work, and I think it's probably one of the two highest value-added cases for the general index, creating improved recommender systems. So right now, recommender systems for finding reviewers, they're citation based, as far as I understand it. So they just look at citations and who's citing what, recent articles that have been cited perhaps multiple times by a given paper. I think that's definitely a valid approach. Could be really, really interesting to essentially enrich that approach with an approach that looks at similarity between documents. And we could have, essentially a simple API that says, you take a PDF and you do PDF as an input, and as an output, it proposes you reviewers, right? And it proposes you reviewers in a way that could exclude authors that have collaborated with each other in the past, right? To like minimize conflict of interest out of the box, right? So that, of course, would require this dual approach of both looking for similarity between papers, but also looking at co-authorship tables to ensure that people haven't been authoring papers together in the past. But it's absolutely feasible. It could work as an API. It could be a simple system, or everyone who's interested in peer review in general, could essentially use that open API to get recommendations. Of course, then we wouldn't necessarily have the email address of the author, so it would just be recommender system which might point to like a Google Scholar profile, and then it would be up to the community who's engaging in the peer review to contact the authors.
So that would definitely be a dream come true. I'm gonna have to figure out how to build that, and really interested to see how the data structures the collaboration between authors, and if that's something that makes it like easy to filter out prior collaborators, or if it makes it difficult. Thank you for the answers.
Definitely be interested to hear a little bit more about how this kind of information and these capabilities could augment the DeSci Nodes platform. Chris, is that maybe something you could talk about for a little bit?
Sure. I mean, definitely in the context of ARC, so these autonomous research communities or DRCs or however you want to call them, I think there's this concept now that's really out and about is, hey, we should create these communities of scientists that essentially do peer review and scientific validation and recapture the value out of that out of the work they provide. So how do we create these effective communities while minimizing ops cost, right? Because when you run a journal, there's of course a lot of ops associated with that. Typically, you look at a journal like PLOS or the big open access mega journals. They have a lot of ops. They have assistant editors. They have staff. They have a lot of staff and work that are essentially doing hard work of running the ops behind the journals. And I think if we want to be able to create a system that allows scientists and scientific communities to capture the value they create in curation, well, we have to think about ways, to reduce the ops, to make that more economically efficient, to gain these necessary economy of scales. And having recommender systems for finding competent peer reviewers is typically one of the things that would help alleviate some of the ops, right? So it would diminish the time commitments to finding competent reviewers, and that would feed into a virtuous circle of improving the efficiency of the process. And you could imagine on an ARC platform that the community would have essentially access to a recommender system, so that when a new DeSci node is created, there would be, for instance, a list of people that would be recommended, to join the conversation around a specific piece of research and to, conduct peer review, perhaps verify attributes, give their opinions, and essentially do the curation value chain. And they could be invited by the ARCs to become themselves members of those ARCs and essentially enrich those platforms and create these types of network effects in which new competent people are recommended to the system that do not necessarily have pre-established affiliations and are not necessarily within the network of the existing scientists within the ARC, which would go yet again to reduce issues such as conflict of interest, such as problems of collusion that could arise, because we're now attracting a more diverse crowd of people who have no pre-existing affiliation. So I think in that context of both improving reducing the ops cost of running these decentralized community, but also in creating a diverse set of participants with lower degrees of connection, social connection between them, that could improve essentially the impartiality of the evaluation in the system in itself. So I think it really adds value on these two angles.
That was super helpful. I've got another question relating to the idea of creating these topics, because one thing actually my team and I are working on right now is trying to figure out how to create different levels of topics. So you have biology, but you also have molecular biology, and then you have lower and lower levels, and everybody has now subfields, and this is something that we've talked about, the splitting of science and stuff like this. So with the Ngrams, what I'm wondering is if we can create these smaller levels of topics in order to get to that really rich. You're not just okay, generally this is in the molecular biology field, but this is in the specific field with the specific with the specific chemicals that we're thinking about, with the specific hypotheses that we're thinking about, with the specific statistics that we're thinking about, such that we can get really high quality peer reviewers, or such that we can just even navigate the space of science. So we're getting to a space where it's a lot easier to know, all right, I'm now in this field of research that I want to be exploring and researching about. So I was wondering how rich right now is the topic exploration, or the topic
so that is straight into the realm of taxonomies and ontologies, and which is an incredibly complex and deep topic, with a lot of gigabrains that have devoted their lives into creating ontologies of foreknowledge. You'll have there's even a bunch of W3C recommendation systems. We've had this. It's all part of this broader concept called the semantic web, and you have projects like OL and others that provide incredibly incredibly detailed ontologies, you also have community-specific ontologies, right? So you could imagine that the needs of a naturalist society studying, a mollusk would have a far different requirements in terms of ontologies compared to a society devoted to, receptors in some subfield of molecular biology. So yeah, it's an incredibly deep topic, and I have spent quite a lot of time actually understanding how we could actually make data fair. Fair meaning findable, accessible, interoperable, and reusable, which is a concept, or you could even call it a meme, that is now permeating academia, and especially academic repositories and funding institutions. And there's this big push to essentially promote this concept of fair. And part of FAIR, a subtype of FAIR, is the idea of having rich metadata and having the elements that are indexed in the repository described with attributes that are part of a common vocabulary or taxonomy, or follows specific types of community-specific ontologies, right? And that is an incredibly high bar to set, essentially. And it has been during that process that I became interested in general index, because I was thinking to myself, well, okay, so we have this very, very big problem of improving the fairness of research artifacts and published research records. Could we actually, bypass a lot of that by using machine learning methods on extraordinary large data sets to automatically start creating these knowledge classification schemes that are consistent and that are not prone to human error? And that would facilitate the life of authors tremendously, because it would reduce the need for them to, let's say, go on a website, find the specific ontologies that corresponds to their branch of work, and then use that ontology and its descriptors, input that into their metadata structures and all of that, right? Which, as we know, is very error prone, and it's also effortful. And we want to essentially reduce these problems as much as we can. So that's where the journal index could really come in and power the process of verification of research data, research artifacts, research article. All of these objects could benefit from this ability to automatically classify them so that they become more interoperable, more findable, more reusable. And of course, there's the other approach, which is, when I enter tag or other people enter tags or these types of metadata, we just, I worked in neuroscience, and at the juncture of neuroscience and economics, so I would just add, things like, oh, this is neuroeconomics, this is game theory, this is, fMRI, and I'd add like a couple of tags that are relevant to my research, which is incredibly valuable to start with, because in the absence of tag, it's very hard to have findable research objects out there, right? So an abstract and a title will typically not allow for optimal findability. That's why you really, really need those tags. And again, if it's something that we could auto-generate, that would add a lot of value. And going one level further is, can we auto-generate ontologies? Well, probably not in the way they are defined currently by DeSci recommendation, which is an incredibly complex model. But we might be able to do it just good enough that we can apply it retroactively to the scientific record and improve the findability of these records, while simplifying the life of scientific authors that want to create these research objects and share them with the world.
All right, cool. That's helpful to think about.
Chris, another question from my end. Could you see, as we're talking about fair metadata and some of the information underlying scientific research, could you see aspects of the general index being integrated into fair metadata structures? Are they kind of already there? Is this something that, maybe a little bit too much for papers? What are your thoughts there?
Well, it would be like a derivative of the general index, right? Because we could have, for example, fields of a specific metadata card for a specific research object, let's say a manuscript, that could be auto-generated by essentially querying the API, which holds the model, by using the text as input and having outputs on the other side, having tags or descriptors or controlled vocabularies. Well, they wouldn't be exactly controlled. It'd be AI-generated controlled vocabularies that would be error-prone to some degree. But essentially allowing authors to modify them and to change them if they're completely out of whack, which I assume a few of them could be. And essentially from that would simplify their process of submitting their scientific research. And another powerful feature of creating research objects is that typically nowadays, when you send your manuscript to PLOS, they publish it, then you put your code on GitHub, then you'll put a video of a conference talk you gave on the topic on YouTube, then you'll have a data set that you're going to save on like whatever field specific repository that you like, or maybe go to a generalist repository like Figshare, and you're going to essentially post all of your artifacts in this very scattered landscape of silos that run on the cloud. And you need to every single time, you need to like repeat what you're doing. You have to put back your tags. You have to explain this is linked to this other resources. And you have to like manually navigate through this vast landscape of different repositories for different types of data formats. Well, with DeSci nodes, you don't need to do this anymore because, we're combining a preprint platform with a generalist repository, and you can, in principle, add arbitrary types of data, and these data end up connected on that particular research object, which improves the discoverability of artifacts which might not have been described with the level of accuracy that you would have wanted them, given the risk of human errors and the problems associated with findabilities on certain types of silos, right? So the idea is that we can facilitate findability by inferring relationships between linked objects that are stored in this Merkle-DAG data structure. And now if we add the journal index on top of it, you could imagine an author who drag and drops his manuscript, adds his data, his code, all these things, and the system would automatically suggest metadata, right? Would suggest metadata for the author that the author could correct or could just, keep as is if it looks good enough, and then submit. And that would, that is a level of UX that just doesn't exist right now in science. And I'm a firm believer that if you make it easy for people to post their research objects, to post their research artifacts, and to share their work, they will come. They will do it more often. And then the next thing you have to do is just give them recognition for doing that. And that's where these attributes come in, where you can have badges such as, you have open data, you have open code, and your artifacts are reproducible. I think these are the type of, not only on the user experience side, but it's also on the recognition side. And those two things combined together would improve the rate of sharing of research artifacts. And that's why we're super excited about what we're building in a way, because we could really, change the incentives in a way that isn't only that authors aren't only motivated by the stick, because that's the problem right now. It's like essentially, you have funders behind you. It's like, oh, have you archived your data on this institutional repository? Have you done this and that? Otherwise we're going to audit you, and you risk you run risks associated with these audit process. And here we can essentially make it easier, and we can encourage authors by recognizing that they're going above and beyond the call of duty. And that's very valuable for funders, for authors, for institutions, for research organizations.
One of the things I'm personally very excited to see is the macro level of DeSci nodes, and the views around findability and just indexability, searchability for every individual node, and an aggregation of larger nodes. So as you kind of think about the scientific ledger of record and kind of the knowledge trees that come out of DeSci nodes being created, some of what Ellie and Chris have been talking about in terms of taxonomy, I am very excited to see the visualizations that come out of that, and to kind of get to experience some of the UI UX that comes from that. I think by enabling better metadata on the user standpoint, we really and truly can create a significantly better system for finding and accessing scientific research.
Yeah, me too. I'm super excited about that. Although I will say that it's something that happens once you already have a super successful product, right? So, but you first need to populate it with sufficient volume such that search becomes a problem, right? So when it does happen, it's a great problem to have, and you're going to be very, very happy that you've thought about it from the get-go, so that you can have an actual effective and high-quality search function. When it comes to mapping out a graph view, I personally, I've worked before with graph theory and graph models in infection disease control using machine learning, and I really love toolboxes like D3 and other types of graph visualization systems that could be used to visualize relationship between nodes, or even different components within nodes in a graphical user interface. So all of those things are like potentially exciting features that we add down the road. Let's see.
Yeah, I'm excited for it. Well, with that, Ian, I have one last question for you if you got a second. What can people on this call do to help you with your work on the general index?
Absolutely. I think I love hearing new ideas of how to actually make this thing work, and like what this could do to help people in their own personal lives for scientific publication, or for finding research or anything about that. If you're more on the coding or data side, obviously checking out the GitHub repo, letting me know if there's anything you see that might be off, or if there's anything that you think would be really cool to see, or if there's something that you would like to do yourself, just like forking the repo. But mostly just like engaging in conversation around it. I think the parts of this progress so far that have been the most substantial have been when Renee has told me about some techniques for NLP work, and just doing so in the Discord and having a quick conversation in the general index channel. Those are always the best. So just continuing the conversation around the general index, I think, would help me the most.
Absolutely. I know a lot of the work that Umar is doing with Scurf around peer review does center around a lot of these concepts, and there's some amazing things that can come out of that. Renee says this call makes her want to quit being a founder and go back to doing NLP research. It's fun to think about. So yeah, for anyone who's listening, if you want to come and help, please just come on the Discord and continue having conversations. We'll be posting the proposal link for general index ideas in the near future, but it's always fun to just come dream about what this data set can eventually become and how the next version of it through DeSci nodes can be used effectively and efficiently. Does anyone have any last questions for Ian, Chris, Ellie, anyone who else has been very active on the call? Okay. Well, with that being said, just a quick reminder, Philip is going to be talking at EthCC in Paris on, I believe, this Sunday at the Sorbonne from 4:05 to 4:20 CET. Philip will be talking, I believe it's on Friday, excuse me. Chris and I will be talking on Sunday at the Research Hub SciCon conference. It is a virtual conference. I'll be talking about onboarding the general public and rebuilding trust networks. Chris is going to be talking about open verifiability and reproducibility. We have product office hours tomorrow, onboarding office hours on Wednesday, and a coffee house immediately after this call. So thank you all for joining. And with that, I think we can end the community call for today. And thank you, everyone.
Thank you, Eric. Thank you, everyone, for participating. Again, great job, Haithian. I'm really thank you for what you've done so far. I think it's really great, and I'm really looking forward to see what can come of it in the long run.
Thank you all very much for having me and for entertaining this conversation. I really appreciate it, and I'm equally excited to see what can come of this. Stay tuned. I think I'm going to try to push something on the GitHub later today if anyone wants to get started on their own. For now, just love talking about it.
Absolutely. So I'm going to go ahead and end this event. If it kicks people out of this channel, really sorry. Let me go ahead and stop the recording here real quick.